Hello everyone, and welcome to Biopedia. Monoclonal antibodies, or antibodies which only bind to one antigen, have a variety of uses. To give just a few examples, antibodies fused to fluorescent markers can be used in research to monitor the molecules they bind to, tumour-specific antibodies can be used to locate tumours, and antibodies binding to the hormone human chorionic gonadotrophin, or HCG for short, are used in pregnancy tests. In the body, monoclonal antibodies are produced by a specific type of lymphocyte called a B cell, named for the bone marrow in which it matures. B cells can produce unlimited amounts of antibody. However, B cells become less useful when you transition from the body into industry. This is because they have a limited lifespan within cell cultures, with different sources giving them lifetimes of either days or weeks. In addition, B cells are unable to divide. As such, a different approach is needed to commercially manufacture antibodies. This is where hybridomas come into play. Hybridomas are artificially hybridized cells which result from the fusion between a B cell and a mutated cancerous B cell. Notably, hybridomas can divide indefinitely and their cell lines are immortal, in contrast to the finite in vitro lifespan of B cells, resulting in a lot of antibody being produced. In order to create a hybridoma, the antigen which the antibody being produced is specific to is injected into a mouse. In the ensuing weeks, B cells with the necessary antibody replicate within the mouse and produce antibodies. B cell-enriched tissue from a lymph node or the spleen is then removed, and B cells are fused with cancerous myeloma cells to create the hybridoma. Now, only a fraction of the fusion events in vitro result in hybridomas which are able to produce antibody, meaning that these need to be selected for. As such, 3 compounds are subsequently added: hyperxanthine, aminopterin, and thymidine. Aminopterin is toxic to myeloma cells because it interferes with their metabolism. Myeloma cells are not able to use hyperxanthine and thymidine to remove the problem, while fused hybridoma cells can. This is because the B cells which went into producing the hybridoma supply the genes necessary to use them. As such, this process selects for successfully fused hybridomas. A process called enzyme-linked immunosorbent assay, or ELISA, which we won't go into today, can be used to locate hybridomas which are able to produce the antibody. Cells can then be extracted and either grown in vitro or as an antibody-producing tumour within a mouse. Antibodies are then extracted, from the tumorous growth itself in the latter case or from supernatant in the former, and purified. Hybridomas can either be grown indefinitely or else stored frozen to be used to create antibody at a later date. Some hybridoma properties derive from either cell type that went into their creation. They produce antibodies like B cells, but their growth and division in culture can go on indefinitely, as per cancerous cells. Advantages to using hybridomas are how pure the resulting antibody is, and that the antibody can be created by the hybridoma in response to an antigen, even if it is only a small part of a mixture of antigens. A final thing to mention is that hybridomas now also exist which result from the fusion of the 2 mouse cell types mentioned above and human cells. This is in order to decrease the probability of the antibodies produced by the hybridoma being rejected by patients' bodies. That's it for today. As always, thank you for listening. For any questions, comments, or topic suggestions for future episodes, feel free to get in touch at the show's email address. And until next time, have a great week, everyone.